So this is question 6 from June 2013, done at the Northern Cape province. It was a set B. I don't know if the question paper was ever done, but this is a good backup for us to practice and so on. This question says, study the graph below which show the change in energy that take place as two hydrogen atoms move towards each other. And in this graph, you need to know that in the y-axis you have the energy, and in the x-axis you have the distance between those two atoms. There is a bonding, there is a video. I'm going to leave the link for this topic. Now give a definition for the term represented by a B. And B is this distance here, there, which in actual fact we're working with the x-axis. Is this distance here, that is what B is trying to represent here, guys, and this one is the bond length. So all they want is the definition for bond length. Alright, and the definition of bond length is the distance between the nuclei of two atoms that has formed a chemical bond. That is the definition for bond length. This is quite simple, guys. So I want you to know that in the graph, that one will represent the bond length. What can we say about the attractive and repulsive forces between the atom at C? I want you to know that at C is the point when the bond can form, because at that specific point, the forces of attraction and repulsion, these two forces are going to be balanced. So at that specific point C, the forces of attraction and repulsion are going to be balanced, guys. That is the point when the forces are equal and the same. What can we say about the potential energy at C? You can see that the potential energy is the lowest one, guys. So you can see that at that point the potential energy is the minimum one there, and then at that point where the potential energy is the minimum is where only the bond can form. Give a definition for the term represented by A, and you can see A here is coming from the y-axis, guys. Is this distance here, and that one will be the bond energy. So that one will represent the bond energy, and we are going to write the definition of bond energy real fast. So what is bond energy? Now bond energy is the amount of energy released when a bond is formed, or the amount of energy required to break the bond. So guys, that is the definition of bond energy. And in this question you need to be sure that they are going to be asking you for those two terms and definitions. What happened to the distance between the two hydrogen atoms from F to E? Now from F to E, and guys, from F to E, if you go to the graph, means in that direction there to the left. So you need to know that as the atoms are moving there, the distance between the atoms, you can see it in the graph, becomes smaller. So at this point the atoms are going to be quite far from each other, so that is why the bonds cannot form. They are too far. But when they are on this point here at E, they are extremely close to each other. They came too close, they cross each other here, and the repulsive forces are going to be too strong because they now too close to each other, so the bond cannot also form. But that is not the question. The question said what happened to the distance, so the distance decreases. Next question, at what point of the graph will bond between the two hydrogen atoms be formed? Guys, that one will be at C. Here at C is where the bonds form. There is the only place when that bond has been formed, so it's at C. We need to know that. You need to learn that at that point, always in the graph, the bond is formed. Why? Because the energy is at minimum and because the forces are balanced. That is the only point when the bond is going to form. So please remember that. What can we say about the forces between the two hydrogen atoms at D? Now, where is it? D is here. Guys, you can see the distance between the particles, which in this case is the atom, is too far. So there is practically no forces. So the forces there is equal to 0. There is no forces. At this point C, as we said, there are practically no forces, guys, because the distance between the nucleus is too far. Okay, now How does each of the following factors influence the strength of the chemical bond? Very important. Now, the size of the atom. What you need to know here. The smaller the atom, the stronger the bond, or vice versa. Now, that is quite simple. If the atoms are very small, we're going to represent here 2 atoms so you can see. Now, what happened? You have one atom and another atom. Let's say this is the atom. And now, the bond length is this one here. All right. What if we make 2 bigger, or we have 2 bigger atoms? Now you can see that the bond length increases, become longer. The bigger the bond length, then the weaker the atom. So that is actually what happened there, guys. You can see there with the representation of the atoms. The smaller they are, the closer they are to each other, and therefore the stronger the atoms will be. Bond length. There we go, the explanation, guys. So the smaller the bond length, the stronger the bond, and vice versa, the other way around. So this one is quite simple. And then bond order. Now I want you to note that the term order, we're referring of number of bonding. Number of bonding. In other words, we're talking about single bond, double bond, or triple bond. That is the bond order. So it can be 1, 2, or 3. That is what we're referring as bond order. So what you have to say is the higher the bond order, the stronger the bond, or vice versa. And vice versa, it means that is the lower the bond order, the weaker the bond. So guys, this one is question 6. I hope it helped. It is going to be asked in the exam now about bonding, and sometimes this question could be confused. But thank you for watching. If you think it helped, thumb up and subscribe for the channel. I'll see you next time. Mr. G here.